Welcome to Work Guide 2. This is Unit 2, where we're going to be covering the topics of field maps, gradient, and topography. So some of those words might seem new to you, but don't worry, future topics will help you understand it. So where we're going to start today is going to be fields and what fields are. And most of the time we probably think of fields like maybe an open space like Central Park where there's lots of grass. In science, we look at a field as any area that we can take measurements from, and then we can start to analyze and process that data to recognize trends, maybe phenomena, something that's occurring around us. So what I need all of you to do, as always, read through your notes, do some annotations, maybe in your Google Doc, that hopefully you have a running tally of notes, or you're utilizing your paper notebook and you're taking your dates and your notes for this. So go ahead, pause. Okay, now that you've come back, you can see that I've done some annotating for you, maybe some examples. I know that annotations don't always come so readily, so here's a few that I've done. Mainly I'm highlighting by circling a definition isolines. I think that's very important, and maybe I might write that in my own words. I'm trying to also explain that we're developing trends, scientific trends, sometimes societal trends. It could even be economic trends, but we're doing trends with fields. Down here we have a formula, contour interval, and this formula is not in your reference tables. So keep in mind, this is where you're going to have to go for it, or that dreaded memorization. So this is really going to calculate for us how much we're counting up by on our field maps. We've got isotherms, isobars, contour lines. All these are types of isolines, each of them connecting different values with different units. However, if we look specifically at just isotherms only connect points of equal temperature. So within each of these, the units are homogeneous. Isobars, you're connecting nothing but pressure, usually air pressure. And then contour lines are lines that connect points of equal elevation, which will lead us eventually into the topic of topography. So let's talk about connecting these isotherms. Now, I know that we are at a remote distance, and even in our classroom we're a bit remote from each other, and drawing out these isolines is not necessarily going to be the main focus of this topic. What we're going to be focusing on is interpreting it, calculating information off of it to develop trends and better understanding. However, I would like to walk you through at least how these things are connected so that you may have a better idea of how the map was created. So first things first, we have to figure out what values we want to connect together. In this case, I am already identifying the three values with units that need to be connected within my map. So I have 22 degrees Fahrenheit, 26 degrees Fahrenheit, 30 degrees Fahrenheit. I want to connect all those. So think of this kind of like a combination of connect the dots and a maze where you're finding your way through a location. So here I have circled all of my 22s, and the 22s have a dot that corresponds directly to where that measurement was taken, and those 22s represent degrees Fahrenheit. So I want to connect all of them. Looking over here, it seems pretty straightforward that I just connect from one to the next to the other, but we also have to be mindful of what's around it, what values are nearby, and what values may interact with the direction your line goes, kind of like that maze. So we're connecting all the same dots, but we've got to figure out how to get to those dots. Now, once we've figured out what path that we need to go through, we want to make sure that we extend the lines to the edge of the map, because even though we don't have dots labeled with 22s all the way throughout this line, everywhere along this line and in this field space is equal to 22 degrees Fahrenheit. Let's take a look at the 26 degree Fahrenheit isotherm line so that we can get a better idea of how I went through here. Yes, it does look rather simple, but it's the concept that's most important. So as we're connecting from 26 to 26, this area is not labeled, but we can assume that it is also 26 degrees Fahrenheit between here. because we have two reference temperatures to view. We have a 22 on the right side, degrees Fahrenheit, and a 29 degrees Fahrenheit on the left side. So if this were a number line counting up 23, 24, 25, 26, that's kind of where we are, 27, 28, 29 degrees Fahrenheit, it looks to me like, so yeah, it seems like that's a good place for my value. Notice also that I'm not putting units on the map. It helps keep the map a bit cleaner to view. And we can use this same method to get our way through the rest of the map so that we can extend and label what that isotherm is worth. Same thing happens with the 30. Now, down here, I'd like to introduce how to utilize the contour interval formula. I've abbreviated it for space purposes. Now, up there it says highest value minus lowest value, and in our case, we're dealing with isolines. Okay? Sometimes we might be dealing with a graph. Like way back in the graphing sunspots lab, there was an interval for each box, but here we were talking about the spaces in between, the isolines. So my highest isoline minus my lowest isoline divided by the number of spaces. So let's at least get our highest and our lowest isoline values, in this case isotherm values, into our formula. So we've got 30, and you know what's missing. Units, because I'm going to be a stickler. And then we've got 22 degrees Fahrenheit. Now from 22 over to 30, we go 1 space, 2 spaces. Don't count the lines. That tends to screw people up a lot. So I've got 2 spaces. And for this calculation, we're eventually going to drop this unit out because it's a unit meant to just help us calculate. It doesn't stay with it. So we simplify now. We've got 8 degrees Fahrenheit on top, divided by 2 spaces. Now that we've simplified, we're going to divide them, and we're going to realize that our answer is 4 degrees Fahrenheit. That is going to be our interval. So that means we are counting up by 4 degrees Fahrenheit each isoline. So if we were to continue this map, so the next highest presumable isotherm would be plus 4, and we'd end up with 34 degrees Fahrenheit. If we were going to the right, the next isotherm going down would be 18 degrees Fahrenheit. And we could continue this map for as long as we have data. So I've already done the legwork of drawing the lines out here, but what I want you to do is to pause the video, and for these 2 questions, in addition to the ones below, we're going to utilize all of these as guided practice questions. So what I want you to do is I want you to analyze the map, look at the data that's given, and calculate an interval with proper units. Down here, I want you to do the same thing. Look at the data, observe it, figure out the interval with proper units. So, as a reminder, we're on page 78 in the notes for this. Go ahead and pause the video, give these a shot, we'll come back. Okay, so you've had a moment to pause, digest, marinate on those 2 first questions, and now we're going to move into more guided practice. And these everything you're doing will be eventually submitted in the guided practice submission form. So here we've got another map, one that's provided to us, but now we have something more recognizable, being the United States, part of the lower 48. Okay? And they have isotherms that are labeled in here. And those lines extend to the edges of the map. They labeled it within rather than the edges. I am not asking you to draw anything on this map because that's a bit difficult at the moment. Maybe future tech will help us. So down here, we're going to work on some interpretation questions. I'd like you to identify the values of isotherms from the map for these points on the map. Also, you're going to calculate and give with correct units the interval for these isotherms. And then I want you to kind of tell me, where is it coldest? Pick a letter. Pick one of the letters on the map to tell me where it's coldest on the map. So So once you're finished with all of your guided practice questions, you're going to be inputting that into the Google submission form guided practice within your work guide. Go ahead, pause, start working on that. As a reminder, with all of the topics that we learned together, we have to make sure that you're also completing your independent practice, which is going to be on the following slide. Then, once you've submitted your independent practice as a homework grade, you're going to move into your challenge slide, which you have lots of opportunities to challenge yourself and also to earn some bonus CP points. And lastly, no matter where you are, if you're here with me live, you will be doing a checkpoint in class. Good luck, let us know if you need help, and we'll be sure to get back to you. See you soon.